Junior Cycle, High Level 2014, Phase 3, Paper 1, Question 2. This question is a basic number question, and it's talking about prime numbers. You've got two formulas here, and you're asked to put in a variety of different values of p into the formula to see what happens. They've done the first one for you here. They've put 0 into the formula. 6 lots of 0 plus 1 is 1, and 6 lots of 0 plus 5 is 5. And you can see so far those two are, well, 5 is a prime number, 1 is not actually a prime number. So we should be able to go through this reasonably quickly. 6 lots of 1, so I'm going down working my way down here. 6 lots of 1 plus 1 is going to be 7. 6 lots of 2 plus 1 is going to be 13. 6 lots of 3 plus 1, well, 6 threes are 18, plus the 1 is 19. 6 lots of 4 plus 1, 6 lots of 4 is 24, plus the 1 is 25. Now, straight away, that sings out to me as being a number that's not a prime number. And 6 lots of 5 plus 1 gives me 31. Let's try it with the other formula. Now, I could go through the same thing. 6 lots of 1 plus 5, 6 lots of 2 plus 5, 6 lots of 3 plus 5, and so on and so on. But I'm not going to do that. I'm just going to do this far more quickly, because I noticed that basically these two, this one here, is just 4 more than the first one. If I add 4 to that, I get this one. So if I just add 4 to each of my numbers, add 4 to 7, 13 plus 4, 19 plus 4, 25 plus 4, 31 plus 4. And now we're asked to comment on both methods, the 6p plus 1. Well, I've already stated to you that 25 is not a prime number and 1 is not a prime number. Okay, so 6p plus 1 does not work. And so we're able to state that 6p plus 1 is not fully correct because 1 and 25 are given, however these values are not prime. And then you can do the same thing for the second one and say pretty much the exact same thing. In 6p plus 5 we have the number 35, and 35 is not a prime number. So we can put that in the reason 2. Okay, so 6p plus 5, incorrect, since 35 equals 7 times 5, it's not prime. Okay. Moving on to the second part, we're asked about a Swiss mathematician, a very famous one. And he's got a formula, n squared minus n plus 41, giving a prime number for all integers less than 41. So he's obviously suggesting once you get to 41, something about it doesn't work. So explain why it does not work for n equals 41. Well, once I've substituted in 41 into the formula, and I should point out to you at this stage that is 1,681, but to be honest with you, that's not really of any importance, because you should be able to realise, well, 41 squared minus 41 plus 41 is 41 squared. Since these two 41s, positive and negative, they cancel each other out. And 41 squared, well, it can't be a prime number because you're multiplying two numbers together that are not something other than 1 and the prime number. We can effectively say that 41 is a factor, therefore not prime.